Hello everyone, welcome back to our lectures. This chapter is about Flume, which is a tool used for message log aggregation and for automatic data collection.
Talking about Flume, we know that it was originally designed by Cloudera for log aggregation and analysis. But today, Flume can do more things than just log aggregation, and in Hadoop ecosystem, we rely on Flume for automatic data collection. We will guide you to learn the architecture of Flume and how is Flume implemented for data collection. Again, before jumping into the main lecture, at first, we can have a look at the objectives on this chapter. We hope that after finishing this chapter, you can be able to know what is Flume, some application scenarios of Flume, the system architecture of Flume, some features of Flume, and finally, you could master how to configure Flume in real applications. Okay, firstly, let's have a brief overview and introduce the architecture of Flume. As mentioned before, Flume is designed for log aggregation and data collection. To be more specific, Flume helps to collect data from different sources, including local files, real-time logs, REST messages, Swift, AVRO, syslog, Kafka, and other data sources. Data collected from those sources can be roughly processed by Flume and stored into HDFS or some other destinations, and then further analysis can be operated on this data. So, it is quite straightforward to introduce the application scenarios of Flume. Here, we can see some descriptions, but in short, Flume helps to collect data from different sources for further analysis. For example, we can use spooling directory to monitor whether there is any data being generated or modified under a fixed directory, no matter whether the directory is in HDFS or in HBase or from Kafka or even from the local Linux file system. And if there is any modification, Flume can collect the new pieces of data in real time. On top of that, Flume supports cascading and data conflation, two concepts that will be introduced in the upcoming several pages, and moreover, Flume even supports data collection tasks customized by different users. So basically, you can see that Flume is really powerful in data collection. Next, let's have a look at the architecture of Flume. In Flume, the most essential role is called agent. A Flume agent consists of three parts: source, channel, and sink. Please pay attention to the names of them, because in Flink, we also introduced three names, which are source, transformation, and sink. Please recognize the differences between them. Here, we say that Flume is used for data collection. That's the reason why there is a channel instead of a transformation in Flume. And in general, they work together to support log collection as well as aggregation. And basically speaking, if we want to use Flume, we need to deploy the Flume agents based on different occasions. As shown in the slide, there are two typical deployment modes. One is the single deployment mode, and the other is multi-agent mode. Firstly, if we just need to collect logs generated by the big data platform itself, or the log system is deployed together with our big data platform, then we suggest to use the first mode. In this mode, we need only one set of Flume agent, and the data collected by this agent can be sent to HDFS directly without secondary transmission. However, if we want to collect data from other clusters, or there are multiple independent log systems to be analyzed, then it is necessary to deploy the multi-agent architecture. For example, here we can see Agent 1 is deployed on the cluster where log data is generated, and Agent 2 is deployed on Hadoop cluster, which is the platform for big data analysis. And between two agents, we can use AVRO protocol for data transmission. By doing so, we will not mix two clusters together, and thus they can remain independent in their own businesses. And moreover, the multi-agent deployment is really helpful for this particular case. In this case, we have more than one log systems to be analyzed, so we need at least two different levels of Flume agents for log aggregation. Agents of level 1 are deployed together with the log systems, and each log system corresponds to one individual agent. Then, the log information can be aggregated by the agent of level 2, and this method is called consolidation. After consolidation, events can be processed into HDFS or other destinations for further usage. This is actually the most commonly seen scenario in reality. And in this slide, we show you an example of collecting logs from three independent log systems. So in level 1, you can deploy three agents for each log system. Then, after aggregation by agent 4, logs are stored into HDFS eventually. Okay, but that is not all for agent. Here, in this page, you can have a look at more principles of it. The first key point here is event, which is a name for the data transmitted in Flume. Namely, the basic unit of data transmitted by Flume is event. For example, if the data is a text file, the transmission unit is usually a row of records. Events are collected by source, roughly processed by channel, and then output by sink. But here we can see, for channel, there is a component called channel processor, which contains an interceptor. Just indicated by its name, the interceptor helps to do some interception work, or namely, it filters data according to some policies or conditions, and meanwhile makes some modification according to user configuration as well. This is important for log analysis because some logs are not necessary, or they do not comply with the further convention rules, or they even contain some wrong information for further computation. We call this data dirty data, and with interceptor, we can filter this dirty data out in case of errors. Moreover, multiple interceptors can be customized to implement multiple filtering. After interception, the correct events are selected by the channel selector and distributed into different channels. In this step, some configurations can also be specified for maximum usage of channels. As for sync, here we have sync runner, which is used to drive sync processor, and sync processor drives a sync to obtain data from a channel. Next, we are going to have a look at the three key concepts in detail. Firstly, source. Just indicated by its name, it is just the source of log information. Moreover, it abstracts the raw data into events, or even helps to generate data by some scripts, then transmit data into channels. And basically, there are two types of sources. The first one is called driver-based source, which is a passive one. That is, the driver-based source waits for the data to be sent by the log system, and it is driven by the external systems only when there is data being generated. Meanwhile, the other type is called pooling source, which is active and asks for data periodically. Here, we mention that a source must be associated with at least one channel, which means that we cannot transmit data from source to sync directly. There is at least one channel in between. This slide shows us the most commonly used sources in reality. Basically, they correspond to different data locations and different data protocols, but there is one exception, the exec source. In most cases, exec source are used to execute the commands or scripts to generate data, and that is why we say a source can generate data itself. And the spooling directory source is also important when we need to monitor a directory and check whether there is any modification. After source, let's have a look at channel. Channel is a queue which caches data temporarily. Here, this temporary is vital because after sent by sync successfully, events will be removed from channel permanently. But in some cases, we need data persisted for later usage, so we can make configuration for this purpose. By default, Flume uses the memory channel, which allows no persistency at all. But if we choose file channel, some write-ahead logs will be created to record the data. Or if we choose JDBC channel, data will be written into the embedded database alternatively. And in channel, events are considered to have some transaction properties like ACID and can be ordered weekly according to user configuration. One channel can connect to any number of sources and things. This slide shows us more details about the three types of channel. Please have a closer look if you are interested in this. Now, let's have a look at the concept of sync. Sync is used to obtain data from channels and place them into final destinations. Again, after sync sends data out, events will be deleted from the channel. And a sync must work with a specified channel as well. In the table below, we have listed several syncs that are commonly used in production. If you are interested, please have a look at this table in details. And we will use HDFS sync and Kafka sync in our examples slightly later.
All right, that's all for the first section about the overview and architecture of Flume. Next, let's have a look at the key features of it.